All right, so we're going to take a look at two more examples using our Calc 2 techniques of evaluating these limits. And so as you look at what we're dealing with in this first problem, we're going to positive infinity. So you can see in the exponent, that's going to go off to 0. So we know we're going to have something raised to the 0. Now when it comes to this, again, as you'll see in a later section, one of these two terms is more powerful than the other. An exponential, we mentioned, is more powerful or more dominant than a polynomial. So if we've got this evaluated at infinity minus something smaller evaluated at infinity, we're going to have infinity raised to the 0 power. So this thing really is just infinity raised to the 0 power, which is, again, an indeterminate form, but not one that we can use L'Hopital's rule currently. So a pretty standard technique now at this point is letting y equal our function and then logging both sides so that we can now bring down that 1 over x. So this is the part now where I generally put a mark on my paper to remind myself to come back and e whatever my result is. But now I can go ahead also and proceed forward with that limit of 1 over x, natural log e to the 2x minus 2x. Now, to be fair, that is the same thing as this x being in our denominator. So if you'd rather see it directly like this, then that's perfectly reasonable. And I kind of like that approach because now we have our distinct numerator and denominator. All right, so a minute ago we talked about how this was infinity. And so the natural log of infinity is infinity over infinity. So without a whole lot of work, we finally hit our infinity over infinity pretty fast. All right, at which time now we can go ahead and use L'Hopital's rule, carrying that limit notation down. We'll go ahead and take the derivative of the numerator separately. So there's the 1 over the inside, back times the derivative of the inside, which would be e to the 2x times 2. And then we'd have minus 2 for that second term right here. Then in the denominator, we would just get our 1, which is pretty nice. So now, I would recommend cleaning this up a little bit without having to do a whole lot. I'll say limit as x goes to infinity, 2 e to the 2x minus 2 over e to the 2x minus 2x. Now you can plug in the really big number again. We've got another infinity over infinity. And that means we've got another iteration of L'Hopital's rule needed. So LH for L'Hopital's rule. Limit as x goes to positive infinity. Now we would have a 4 e to the 2x over 2 e to the 2x minus 2. So now let's reevaluate again at this really big number. Well, we have another infinity over infinity, which is fine. It doesn't tell us anything just yet, but it also hasn't gotten us in any trouble. So we've got another infinity over infinity, in which case I'll go ahead and run another iteration of L'Hopital's rule, carrying my limit notation down. Now I'm going to have an 8 e to the 2x over 4 e to the 2x. Well, now these e to the 2x's can go away, leaving us with a result of just 2. So this one took 3 iterations of L'Hopital's rule. It's not that it was a very difficult problem, but it was a nice example to show that if you're still needing more information but not really running into any trouble, you can still use L'Hopital's rule. Also, don't want to forget, we logged it, so now we need to e our result. So the answer to this limit would be e to the second. All right, so this last example we look at is going to be a very, very interesting result. Now, I want to go ahead and I want to take a look at it a little differently. Now, again, you could certainly use L'Hopital's rule on this, and I would strongly encourage you maybe after the video to go ahead and try that for yourself. But I'm going to use a substitution here and use an earlier result. So I'm going to go ahead and let u equal 1 over x. Okay? If u equals 1 over x, then our x would have to equal 1 over u. Okay? Also, pay attention. If x goes to positive infinity, which we can see x starts off by going to positive infinity, If x goes to positive infinity, then our u would go over to 0. So by making the substitution now, limit as u approaches 0 of 1 plus u raised to the 1 over u. All right, so all I did is I substituted the u going to 0 that we talked about. I took the 1 over x here, and I substituted that with u. My x value now was the 1 over u. So again, I've adjusted all my variables accordingly. And if you take a minute, this guy is something that you probably recognize. This was something back from the first section of the course, or maybe the second section, I can't remember, where we defined this as e. So the answer to this limit, which is this limit, is e. I mentioned as we started this problem, I think it would be a good idea, go ahead and pause the video now, or end the video because it's almost over, and rework this limit right here using L'Hopital's rule. You'll end up having to log the function, bring the x down, and then from there you can figure it out. But you would end up with a 1 for that limit, and then when you circle back and e it to undo the log, that gives you that e as our final answer. So a pretty interesting result.